So welcome everyone to the first meeting of our fall. Yes, it is by Zoom once more, but we hope to see that change over the coming months. We'll keep you posted on that one. Welcome everybody from near and far. We've got folks from the United States, from out west, from Newfoundland. And at this part, I'm not sure of anyone else internationally, but welcome all. Hope you had a wonderful summer. I know from our end, we've been quite busy, and I'm assuming everyone else has had the same experience over the past few months. So I was just going to share my screen here for a moment. So like I said a moment ago, welcome. It's Halifax Centre. I'm Judy Black, its president. You can reach us several ways. You can get our website at halifaxrasc.ca, on our YouTube channel, which is where this video will be posted. And you can also reach me and my successor at president@halifax.rasc.ca. First, like to acknowledge the Indigenous land on which we are sitting. We're acknowledging the Mi'kmaq, the ancestral and unceded territory of the Mi'kmaq people. This territory is covered by the treaties of peace and friendship, which Mi'kmaq and Maliseet peoples first signed with the British Crown in 1725. The treaties did not deal with surrender of lands and resources, but in fact recognized Mi'kmaq and Maliseet title and established the rules for what was to be an ongoing relationship between nations. Also, our center welcomes everyone. We believe in and practice inclusivity and diversity. All are welcomed regardless of age, disability, gender reassignment, marriage and civil partnership, pregnancy and maternity, race, ethnic origin, color, nationality, national origin, religion or belief, or sex and sexual orientation. And we are opposed to all forms of unlawful and unfair discrimination. Our agenda today, we're going through the welcome and acknowledgements now, but we'd also like to welcome our special guests. We have Donald Beddard and Jim Johnston. We will give them a more formal introduction shortly. But they are, in essence, our keynote speakers today. Dave Chapman will all be following that with What's in a Name, How Celestial Objects Are Named. David Hoskin, who is our observing as well as our outreach chair, will describe what's up in the September skies. I will give a brief summary of what's the news from the board. And there's a new segment this meeting called Let's Talk About. Those of you who are familiar with our center know about the Astro Chat, which we will still have. But we thought we'd have this little segment called Let's Talk About. If there is a topic that people are just burning to raise and would like some further input, for instance, about the defense station that's going up near Canso as an example, if that's something people want to talk about, or maybe there's a piece of equipment that you'd like to discuss because you've had some challenges with and need insight on. So let's just talk about its floor is open. And then once that is finished, we will then shut down the recording and it'll go into Astro Chat. And that's the informal part of our meeting when members who choose to do so and guests can join us and just have an informal session and say, how's everything? First thing on our agenda is I'd like to introduce our guests. First of all, we have Dr. Donald Beddard. I'm going to have to read this. These two gentlemen are quite interesting when you read their bios. And I'd be really interested to find out how these two souls met. Dr. Beddard, he joined the Canadian Armed Forces in 1990. He obtained a Bachelor of Science in Space Science at the Collège Militaire Royal de Saint-Jean in 1995. He then obtained his Master of Science in Space Studies from University of North Dakota in 2002, when he was also selected for the Space Systems Group at the Defense Research and Development Canada, where he occupied various roles, most notably the NEOSAT project manager, the joint project manager and space systems group leader. Then in 2013, he obtained the title of Doctor, PhD from RMC, and he was also assigned an assistant professor in the Department of Physics and Space Science at RMC, where he also led a research group focused on space surveillance. And during the last 2 years in uniform, he served as the project director for the Surveillance Space 2 project. And then in 2020, he joined the DRDC as senior defense scientist. And then in August, much to my not surprise, so much as, how do I find him? because he moved into, I didn't know where, but he joined the Arthur B. McDonald Canadian Astroparticle Physics Research as its next managing director. So he's got a brand new title, not even a month old. So congratulations on that, Dr. Beddard. And then with him today is Jim Johnston. He's a registered nurse. He earned his Bachelor of Nursing from Memorial University in Newfoundland in 1999. He's currently working as an occupational health nurse on board the Hibernia platform since 2005, working 3 weeks on, 3 weeks off. In 2016, he started doing astrophotography and has since received his Deep Sky certificate from the RASC. So congratulations, Jim, way to go. He's now acting treasurer for the RASC St. John's Centre. And he's been married for 20 years as of this past week. So congratulations, belated happy anniversary. And he's got 2 children, Tyson, who's 13, and Carissa, who's 11. So welcome, gentlemen. We're really looking forward to your presentation today, and take it away.
Awesome. Thank you very much for the introduction. I'll actually talk about how Jim and I met partway through my presentation. So I'll start by sharing my screen. And I'll ask you if
There we go.
You should see a slide right now. Can
Yes.
you see that? Great,
Yes.
That's awesome. I'll just see if I can. All right. So the topic of my talk today is space surveillance and the Intelsat 1002 servicing mission. So actually, I think the main course of this presentation is talking about the experiment that Jim and I did observing the Intelsat 1002 servicing mission. But before I talked about that experiment, I thought I'd start with space surveillance, which is going to give you background as to why we're doing this research. Before I get going, I'd like to first acknowledge my colleagues or my co-authors that have worked on this project. So there's obviously Jim Johnston, who you've been introduced to. He collected the imagery. One of the next colleague of mine is Mr. Jack Warrow. He's a 4th-year space engineering student at York University, and he worked for me for a whole year in 2021 as a co-op student in the space systems group at DRDC. So he played a great part in processing the data, and to this day still works with me to finish the processing and the analysis of the data. Next also is Captain Shane Royal. He's an RCAF, Royal Canadian Air Force officer, currently assigned to the Space Systems Group. So he worked with me on this project. And then finally, what I'd like to say is, as Judy mentioned, I have resigned from DRDC effective 31 August. So for all intents and purposes, I should not be, well, I won't be presenting anything with the DRDC logo or slide decks on the future. But given that I had accepted to present this presentation when I was still with DRDC, and all of the work that you'll see today is was conducted when I was a senior defense scientist paid by the Canadian government, I thought it would be appropriate to still keep the DRDC logos on all the slides, since all of the work, the IP, still belongs to the crowd, or to the crown, sorry. So moving on, how many of us rely on space capabilities? And I'll start by asking, are you using services offered by satellites? And I've given a lot of these presentations to crowds, and I usually start by asking people to raise their hands up. And I'm always surprised to see how little people realize how much they're actually using, and perhaps more importantly, dependent on space services. So we're all aware of satellite TV. So some of us still have dishes in our backyard. If you live in Halifax, some of you might be sailors. Obviously, if you go off to the sea on your sailboats or your other types of boats, you're probably using some type of satellite service to either locate you on a map, GPS, communication, and so on. If you used your car, or if you've bought a car in the last 5 years, you've probably got GPS in it. So that's using satellites. If you're like me, every morning when I get up, I look at the weather. most of the weather information, if not all, has components or data provided by satellites. And finally, your ATM machines. Every time you use Interact, your credit card is using some service provided by satellite. So without perhaps knowing it, each and everyone uses data provided by a satellite or generated by a satellite between, opinions will vary, but between 8 to 15 times a day. Are there any other users of satellite services? Is it just us Canadian citizens? Or I believe we have an American with us. American? Actually, your energy grid synchronized using satellite service, your cell phone, the timestamps provided by the GPS, your bank machines, stock market, the banking systems, all rely on information provided by satellites. And the list, as you can see, goes down. So should satellites services be affected or even go down, not only would our personal lives be affected, but our nation, the ongoing, everyday business of our nation, whether it's civil services or commercial services, would be affected. The bottom line, space is now seen as an invisible utility. The Canadian government has not yet decreed that space is part of the national critical infrastructure. However, if you look at the last defense policy that was published in 2017, that was the first time that space was displayed or written so prominently in a defense policy. I believe the term appears 100 times. And if you look at specific directives that the policy provides, essentially there are, guidelines that the CAF and D&D are supposed to abide for. So the RCAF will acquire space capabilities meant to improve situational awareness. We are going to, or I shouldn't say we, I'm not part of the D&D team anymore, but D&D and the CAF will defend and protect military space capabilities. And actually, it's not just military space capabilities, but it's also Canadian or space capabilities that Canadian rely upon. More importantly, Canada's D&D will work hand in hand with other Canadian government departments to promote the peaceful use of space by providing leadership in shaping international norms and responsible behaviors in space. So I've talked about now the importance of space in your lives, in the importance for Canada as a whole. So now, why do we need space surveillance? Well, let's look at the situation, the space situation before 2007. A number of nations operating in space was actually not that many. There were much fewer nations operating in space than there are today. And those operators, or their space operators, were mostly limited to national governments. Notwithstanding the harsh physical environment that our satellites and spacecraft are exposed to when they are in space, adversarial behavior in space was not observed. Generally, the nations, the companies, the agencies operating in space followed a certain behavior that was acceptable, or basically that put no one else at risk. So back then, before 2007, the emphasis for space surveillance was focused on what we call catalog maintenance, to maintain the orbits or accurate orbits of objects, satellites in space. And the reason we needed to maintain accurate orbit ephemerides was, for the first part, keeping informed on the objects in Earth orbit, knowing who's who in the zoo. Next, a great part of maintaining accurate orbit was providing space mission support, so pass management. When does a satellite pass over my ground station so that I can either provide commands to my satellites or download the data that I need? Or another aspect of using these accurate orbits was general space mission planning. If I wanted to know when a remote satellite, remote sensing satellite is going to be over a specific area to collect some sort of imagery, I needed to know the orbits of that satellite. And next up, final on the list was collision avoidance. Back then, before 2007, although the term space debris and collision was known, the number of objects was so low that this was not something that was talked about very often. So I talked about how orbits, just in case some of you aren't too familiar with this, how do we define orbits? Typically, they're defined by 6 parameters. And that figure that you see on your right, essentially a true, well, the altitude, obviously, the inclination of the orbital plane, and so on, are part of these 6 parameters that can either be defined as the classical elements, what I've just provided you, altitude, right, the inclination of the plane, true anomaly, and so on. We can have position and velocity vectors. So those are your x, y, z, and then your velocity in vx, vy, vz. And those aren't very intuitive when you look at that. They won't allow you to, just based on those 6 parameters, to know what type of orbit it is, but it's highly a useful format when you're computing orbits or you want to know something about the orbit. And then the 2-line elements. And a lot of astronomers or amateur astronomers I've talked to that have tracked satellites typically use those. The 2-line elements is a system that was devised by the United States government in support of their space surveillance program, or essentially their US space surveillance network. These TLEs are fed into an algorithm that's called the SGP4, Special General Purpose Propagator, I guess version 4. And when you put those TLEs in that propagator, you can then get an idea of that orbit and then the information that you're after. If you want to observe it, then you know when and where to point your telescope. And this is what a 2-line element looks like. Basically, if you're thinking, wow, that looks like something out of the 50s, that's exactly it. This is straight out of the 50s. We're still using it today for a variety of reasons that I won't get into, but the system, for all intents and purposes, you know, for the simple stuff of past management, wanting to look when and know, wanting to know when and where to look at, worked perfectly fine. So some of you, if you go back to your first year physics, where you probably learned a bit about orbital mechanics, are thinking, well, why do I need to track the same object again and again, right? If I remember from my first year physics, once an object is in space, in orbit, you know, classic 2-body system, it should remain on that orbit until the end of time, unless, you know, a force acts upon it. And that's exactly it, right? There are many forces that are acting on satellites or space debris, or what we call artificial space objects. You know, that problem that we got in our first year of physics was basically assuming that, you know, when an object was around a central body, it was a perfect 2-body system, 2-point masses in orbit about each other. In reality, the Earth is not a point mass. You've got an image here at the top right that shows you that the Earth is actually an oblate spheroid. Like my orbital mechanics professor at the University of North Dakota used to tell me, it's sort of like an older gentleman, a bit heavy on the belly and a bit light on the hair. So essentially the Earth is not a perfect sphere, and that's going to affect the orbit. You've got areas of the Earth where there are depressions, right? Thinking of the oceans, and then area where there are concentrations of masses. Think of, you know, the Himalayas, K2, and where there's, you know, a higher density of material. You've got other celestial bodies that are present. The sun is going to be affecting those satellites in orbit. The moon is another body pulling on the satellites. Believe it or not, Jupiter, Saturn, these planets will also have an impact on the orbits of our satellite. We've got solar radiation pressure, the dynamic Earth atmosphere, right? With the solar cycle, our atmosphere is going to puff up, puff back down, and then you've got maneuvers. So all of these factors combined requires us to look at objects over and over again. And new challenges have also arrived, right? After 2007, or near about 2007, new space technologies started changing the way that we needed to perform space surveillance. First of all, we started seeing smaller and smaller satellites appearing at all orbital regimes. So nowadays, you can see, you might have heard the term CubeSat. So whereas in the past, when I grew up, when I was a kid, satellites were huge, vehicles that, about the size of a school bus with solar panels. Nowadays, this is my water bottle, CubeSats, look about this like this, and they're performing operational missions. So the detection problem becomes a lot more complex. We're also seeing, sometime around the mid 2000s, so around 2004, 2005, we started seeing more and more multiple satellites flying in tight co-located clusters that in geostationary orbit. So whereas in the past we could have looked at, one field of view and seen only one object, now we're seeing, up to 3, 4, 5, depending on the size of the clusters, object, operated very closely to each other, relatively speaking, right? We're seeing changes in the propulsion system, going from impulsive chemical rockets or propulsion systems to all electric, where the change of thrust is continuous instead of almost, instantaneous. And then we started seeing on-orbit servicing technologies, satellites going up to another satellite and performing work to fix, repair, or maintain that satellite. You can also think that, right, if we've got a situation of a satellite can maintain another one, that technology could also be used perhaps on a more, I guess, nefarious, for lack of a better term, purpose, right? To disable or perhaps to interfere with the normal operations of that satellites. So that situation required us to start changing the way that we thought about space surveillance and the way we conducted space surveillance. Another big aspect of the problem is space debris. They're posing an increasingly mounting threat to space operations. Here, what's a space debris? Anything that's typically human-made, that's not functioning, so anything that is not operational, stays in orbit, is a space debris or space junk. And there, on that figure that is provided by NASA, you can see sort of a breakdown of what the debris are. 17% of the debris population, expended rocket bodies that are still in orbit around the Earth. Mission-related debris may be stuff that was ejected from a satellite. Another more perhaps funnier example is an astronaut literally dropping a tool while doing a spacewalk maintenance on the ISS. 22% are non-functional satellites, so satellites that had an operational mission, but at the end of their lifetime, instead of being deorbited, they remain up in Earth orbit. And then almost 40% of that population is fragmentation debris. So basically fuel, batteries, paint, flakes, as from separations of rocket bodies or satellites from the rocket bodies, or just satellite breakups. This is what is known as fragmentation debris. And here around that screen, you basically have an idea of what those types of debris are. They range from dead satellites, you see on top here, Annex C3. Below is upper stage, an initial upper stage, which is an American debris. And then here at the bottom is just slag from solid rocket boosters. Perhaps you've heard that it's now dated a few years ago, but this is perhaps the most publicized piece of space debris, courtesy of Elon Musk. I believe he launched his one of his first cars, electric cars that he made. It's now in a trip around the solar system. So why are space debris dangerous? Well, debris remain where the satellites are. If we put something up in orbit, I've talked about how the orbits are going to change over time, but they're not going to change that much. Aside from the debris that are in low Earth orbit that eventually will burn up, if you go into any higher orbit, higher than about 1,000 kilometers, space debris are going to remain in Earth orbit for, you know, all intents and purposes, all of humankind's history, right? And here, what you see on the screen are examples of the orbit that are most useful to humankind, right? The LEO, low Earth orbit; MEO, mid Earth orbit. That's where all your GPS satellites are. GEO, geostationary orbit. That's all where the comms and weather satellites are. And then HEO, highly elliptical orbit. Again, comms, remote sensing. Those, you know, while space is big, most of our satellites are focused in these general type of orbit. You might think, well, surely a small piece of space debris isn't that important. Well, in orbit, velocities are quite high. In low Earth orbit, you're typically going at about 7 kilometers per second. Up in GEO, I believe, if memory serves me right, we're talking about 4 kilometers per second. So you can imagine that at 7 kilometers a second, even if you're small, like in this image here, you know, this is an impact of at 6.8 kilometers per second. Just that little ball caused that big hole. So you can see that something very small could effectively ruin an entire space mission. This is just an image provided by the European Space Agency that shows the images of the satellite, the objects that are overblown, but just to show you how much junk there is up there. And actually you can see, right, I talked about most of these space debris and satellites are centered in specific regions: the GEO, the MEO, the LEO, and the HEO orbits. So the more objects there are, the higher the risk of collisions. And in our field, collisions sometimes we'll refer to as conjunction, nice scientific term. And you can see this is taken a while ago. So I think the last, this is dates by 2 years, but you can actually see, and I'll just see if, yeah. So you can actually see what the risk of on-orbit collision poses. If you look at, can you see my
Yes.
mouse as okay, so you can see that, you know, the first satellite was launched in 1957, and that sort of brownish line is the total amount of objects in Earth orbit, and it's steadily increasing, and sometimes, you know, increases, decreases, and those are where we've got solar maximums. At solar maximum, our atmosphere is going to puff up, more air resistance, so a few more things are going to come back or burn back up in our atmosphere. And then here you see the Chinese anti-satellite test in 2007. Remember when I talked about 2007 being a sort of a game changer year where we had space surveillance before 2007 and after? Well, this event, you know, one anti-satellite test generated about 4,000 pieces of space debris. You can see that big jump, right? And then, so that was a deliberate test. Well, to prove technology that had, you know, very bad consequences for the Earth orbital environment. If you look then a few years later in 2009, there was this accidental Iridium Cosmos collision. So Iridium being an operational US satellite, Cosmos was a defunct Russian satellite, collided, generated about 2,000 pieces of space debris, right? So just one collision, you see these big jumps. That's the risk. So what can we do about it? Well, obviously, we can minimize the stuff that we leave up there, deorbit or send to graveyard orbits. And that's not the topic of our presentation today, okay? That's not enough. We need to track and monitor everything that's up there so that we can, if we can, you know, eliminate or try to stop these collisions. So by tracking, how do we track everything that's in orbit, or at least try to? Well, the number one system in the world that does this is the US Space Surveillance Network, which you have a sort of a graph that shows where all the sensors are here. And Canada has actually been contributing to the US Space Surveillance Network since the 60s. Some of you might remember or might have known that we had some optical sensors in New Brunswick, St. Margaret's, an Air Force Base, and we had optical sensors in Cold Lake, Alberta. Those were taken offline. These were optical system working with film, basically looking for objects and then, you know, updating the orbits. 1990, with the budget cuts, essentially, and new technologies coming in, the government of Canada, the CAF, decided that, okay, we're not going to be in the space surveillance mission anymore, but quickly realized that no, they wanted to be they wanted to be an engaged, contributing partner. So they started looking at how could we do this differently and perhaps more cost effectively. And so the Sapphire project, which you see here to the top left, was born sometimes in the mid-90s. It was eventually launched in 2013 and became, Canada's contribution to the US Space Surveillance Network. At the same time that Sapphire was launched, we had an experimental space surveillance sensor, NEOSat, a project that I managed early on in my career, that did, for all intents and purposes, the same mission as Sapphire. The only difference was Sapphire was an actual operational sensor that provided operational data from the Canadian Armed Forces to the Space Surveillance Network. NEOSat was an experimental tool that DRDC, Defense R&D Canada, could use to experiment with space surveillance concept. So we do have ground-based optical sensors in Canada, and they're all experimental systems. What you see here to the right here is, or left is our sensor in Suffield. And then I believe the one on the center is in Valcartier, Quebec City. And then here to your right is the one that we have in Ottawa. In all, we collect imagery, and with these sensors, we do research on how to improve and space surveillance in Canada. So what does actually looking at an Earth orbiting object, a satellite, or space debris look like when looking through a small aperture telescope? Like this. Obviously, we can't spatially resolve. We can't see, a picture of the satellite. What we're going to see, they look like stars, depending on how you're tracking it. An acquisition in star stare mode or sidereal stare mode, essentially we're tracking with the stars. We know when the satellite's going to go in our field of view. We open the shutter. Our stars are going to appear as point sources. And then in this case, our satellites are going to streak through. And what you're looking here is an image of Anik F1 or Anik F1R and Anik F1 and G1. Here, the other way that we can use our track satellite, observe satellite, is essentially using the TLE. We can track on the satellite, and then when we're ready for it, we open our shutter, expose. Now our stars are going to streak, and our satellite is going to appear like a point source. So what do we do with these measurements? Well, we can use essentially when we do astrometry on it, when we sort of do a plate solution using the stars, we can then get the positional measurements for the satellites to update their orbital element. And this, for the most part, is the essence of space surveillance. The next thing we can do is, if we collect multiple photometric measurements, we can now start characterizing or learning more about the object. So in this case, we'll collect a series of objects. And essentially, we'll just measure, we'll do photometry on the object of interest, and then we'll plot the photometry as a function of time. And as you can see here, this is an example, a light curve that you've probably seen if you're looking at asteroids or you're interested in planetary transits. Same type of concept, except here we're looking at satellites, and for GEOs, their phase or their light curve are very predictable. A rotating a space debris, a rocket body that would be sort of rotating in orbit as such, would have a sort of a sinusoidal pattern to it. So now that brings me to the Intelsat 1002 servicing mission. So I've given you a background of space surveillance, very quick. I realize that, but why we do this at DRDC, why it's important for Canada and for Canadians. So about 2 years ago, when I first joined DRDC as a civilian, at the same time, there was going to be this interesting mission. Intelsat 1002 is a geostationary satellite, communication satellite, that was coming to the end of its useful life. The operators, wanted the comm system on the satellites were still working nominally. The only thing that was needed was to, perhaps add more fuel so that the satellite could maintain its orbit, and maintain its attitude. So they came up with a concept to basically service the satellite so that that servicer would provide the propulsion, the attitude, so that the comm services would be maintained. For us coming at the RDC, this sounded like a perfect opportunity to see how a servicing mission or a conjunction would look like, and how could we tell whether something is changing on our satellite. Well, here's a nice actually overview of what that MEV2. So MEV stands for Mission Extension Vehicle. This was the second mission to be done. The goal of that was to extend the life of the Intelsat 1002 geostationary satellite. It was launched in August 2020, and it docked with Intelsat 1002 about 7 months later. And what you see here to the right is a photo credit from Northrop Grumman, essentially of MEV2, taking a snapshot of the Intelsat on its backside. So the backside is now illuminated by the sun, so hence why we can see this nice pretty picture of the satellite, and MEV2 is just at the back of it. So for us at the RDC, this was an opportunity to observe how the servicing mission would affect the Intelsat 1002 light curve. The only problem, and so before I talk to the problem, experiment objective, well, we wanted to assess whether time-resolved multicolor photometric measurements, or light curves, could be used to reliably detect and characterize a docking event, right? The long-term objective was to develop and test observation procedures and data analysis technique for efficient multicolor photometry, and to assess the military utility of using light curve to detect, for the purposes of military missions. Secondary benefit is that we needed to write this whole new set of codes to analyze the data. So before now, I told you at the beginning of the presentation, I would tell you how I met Jim. The unfortunate thing about this Intelsat 1002 servicing mission was that it was going to occur over the Atlantic Ocean, where Canada does not have nice telescopes or government telescopes to observe the mission. So when I looked at the map and started looking at, what the geometry would be, I started thinking that I needed someone either in Halifax or on the East Coast that would have a nice telescope or a telescope setup that would be able to conduct the observations for me. So back in July 2020, I sent an email. I believe I sent one out to RASC Halifax. I sent one out in St. John to see if there was anyone interested in conducting this experiment with us at DRDC. And fortunately for me, Jim answered the call, and not only did he become a colleague, but over the years, we've, I think, become virtual friends. Eventually, I make my way down to St. John's and meet him in person. And at this point, Jim, if you're ready, I'll pass the slide to you, and I'll flip the slides. You just have to tell me when to flip.
Yeah, sure. First of all, can everyone hear me?
Yes.
Okay, perfect. Yeah, so we had various options available, I guess, for our different equipment that we could have used for our imaging for obtaining the data on Intelsat. What Don eventually decided on going with was I did have a Explore Scientific ED 127, which is an airspace triplet refractor. And that gives us a focal length of 952 millimeters at about an F ratio of 7.5. I did have a Celestron 11-inch SCT available as well. And I think we had contemplated probably using that, but for my setup, I kind of thought that the refractor would work better on my end, just logistically, I guess. Had a couple of different cameras that he could have chose from as well. We eventually ended up, or I should say, Don ended up deciding on the ZWO ASI 183 mm. And of course, with that, we would require a filter wheel for changing the different filters and stuff. Unfortunately, COVID kind of came in a little bit, and we were unable to source the proper photometric filters at the time. So for the first year, we ended up using filters that we had available. And I had a full set of Astrometric RGB light filters, 1¼ inch. So we ended up using those for the first year. Now in the second year, when I don't know if Don's going to be talking about where we repeated the experiment post-docking, but we were able to acquire some photometric filters. And initially we did do a trial run with those, but we ended up going back to the astrometric filters. So just to give you a field comparison, this is just some images that I had taken with the same imaging train in the previous slide, of just some deep sky objects over the last couple of years. So just gives you an idea of the field of view that we were dealing with. So some additional equipment that was required. I did end up using my Starwatcher HEQ5. Did have a bit of a panic moment about 3 or 4 weeks before we were due to start. I was originally going to be using my Optron CEM60 mount, but I had a technical glitch. One of the boards decided to die on me about 3 weeks before we started doing the experiment. So I kind of got in a bit of a panic, and we ended up having to use my HEQ5. And once we started doing that, I just kind of stuck with what worked, and it seemed to work really well. Keeping in mind, obviously, that for this experiment, we didn't really require much in the way of tracking. It was more of a stationary thing. Some other equipment that we use, I did use, or all my PC things were ran on an Intel NUC, which is a mini PC. If you look at the picture, you can see it mounted just forward of the mount, just underneath the telescope. The black box right underneath the blue box.
Oh, there.
Yep, there you go. The blue box is a Pegasus Ultimate Power Box. So for those of you who aren't familiar with that, that's a control box that you can pretty well run everything remotely. You can turn on and off power, different power sources, and you can turn on and off different USB ports and that sort of thing. Of course, we did have to use a guide scope because we would have to take calibration images on calibration star fields. So that would require tracking, that sort of thing. So for that, I used a ZWO 30mm guide scope and a 120mm guide cam. And then for focusing, that was done with a moonlight focuser and, of course, your dew straps. Because in case you guys weren't aware, it's a bit humid here in Newfoundland. So just to speak to Don's comment there about how low in the sky this thing actually is, even from my vantage point, that'll give you an idea. So that's actually pointing at the satellite. So it's just barely above the horizon, even on the extreme east coast here. I'm located in CBS, which is on the Avalon Peninsula, about 52 degrees east or west, sorry, of the meridian. So we're pretty far east. Yeah, so I don't know if you want to take it back from here, Don, or
I will actually, because I've presented this slide to numerous operational stakeholders on my side, people in uniform, and even some of my scientific colleagues and supervisors, and that just blew my mind. So over the 2-year period, I think we collected I think we've got close to 40 nights of imagery. And I'm not too sure half, but a significant portion or non-negligent portion of these nights, Jim was actually on the Hibernia station collecting the imagery. So he was essentially, well, obviously not in the middle of the Atlantic Ocean, but he was far in the Atlantic Ocean. And he would control his observatory from that, collect the imagery for us. It made me jealous because, after years of trying to go through all the red tape and stuff, we still to this day have a lot of trouble using our observatory remotely, just like Jim did. And this is a sample image, typical image of the star field that we collected. So in the center here, what you've got is Intelsat 1002. And then, when I talked about clusters, those are 3 other geostationary. Here's a little LEO going by. But you've got essentially over the course of a night, this was a complete night, basically made a quick video with the satellites. You can see we had to deal with clouds, haze, And in that video, you can actually see the brightness of the satellites changing over time. Towards the end, or as MEV2 was getting closer to Intelsat 1002, eventually we started seeing a fourth white dot, or actually a fifth white dot on this image that just basically would dance around this cluster, and eventually just merged with this white dot. Sorry. So this is, so now the next 3 slides are preliminary results of the data we've collected, and today I've selected to give you the 20 March 2021. These were all the detected objects that we got in the G-band, in the green filter. And you can see that what we're looking at are light curves. They've got some structure to it. This is not a random sort of photometric points as the function of time, but there is structure to this. And the one we're interested in is the blue line. So here we can see that as the night progresses, the satellite becomes brighter, and then it's got the sort of what we call the Batman ears. It's going to become bright, it's going to dim a bit, become bright again, and then as the night wears on, it becomes dimmer. The next one that we were very interested in was the orange dot. So this was the MEV2 vehicle. And you can see here that, it becomes bright, just like Intelsat 1002 at a different time. And that's caused in part by the different shape of the vehicle, its different orientation with respect to the observer and the sun as compared to Intelsat 1002. And other characteristics. So its phase function, or its light curve, is very distinct, right, from the Intelsat 1002. And then our other satellites in the field of view, you can see that we can certainly differentiate between Thor 6, Thor 5, which are also COM satellites, when compared to Intelsat 1002. So the first objective of that experiment to show that characterization, or the acquisition of light curve, could help us differentiate between satellites, which we already knew, is proving yet again. Now, what we wanted to see was if we collected these measurements in the 3 bands, so in green, or blue, green, and red, right? And then we did time-resolved color indices. So we basically did, for all intents and purposes, had a light curve in the green, light curve in the blue, light curve in the red, and then did B minus V. What could we get from this? Could we get, the different colors or reflections off the satellites? And you can see from the data that right now, there are some features, not that we've been able to, none that we've been able to say, okay, yeah, this points to like a definitive signature that can be repeated for that satellite. We're still working on it. We're still going through the data. We've got about 40 nights worth of data that we're sifting through. The one thing, we did the same thing with MEV2, and you can see that, we can see some shapes in the data, but nothing that, allows us to come to concrete, reliable, and definitive data about very specific characteristics about the spacecraft. Finally, though, the interesting thing is, could we determine, between prior docking to, could we differentiate between, has a docking event occurred with our satellites? Well, if you look at this plot here, the red, or the blue and the orange line, were all pre-docking. And you can see that for all intents and purposes, the phase function or the light curve resemble each other. On the 21st of April, 2021, the docking had occurred, and now we see that the light curve has changed. Our analysis of the future other light curves that we've collected after that date all show the same pattern, that yes, there is a distinct change between what Intelsat before and after the docking. We're still working on it. Even though I left the ERDC, the students that I enrolled or that started working on me went back to York, and I'm continuing my collaboration with them part-time And we're looking to complete the version of our software that we basically use to analyze the data. We're about 95% there. We're just dealing with bugs after bugs, and we're doing this on a part-time basis, hence the time it's taking. We've almost finished processing all of the observations, and the goal is to eventually finish that DRDC technical report. Although I've left, that's one of the things that I want to be able to point into the future, is that, you know, we did this study, here are the results, and it's available not just for the military, but this report, like most unclassified reports, are available to the public. So with that, I think I went over time. For that, I apologize, and I'll open the floor for any questions. Do you have any last comments to make, Jim?
I was just going to point out that the gap in some of the curves was not from lack of data. It's from when the satellites actually went into eclipse.
Yeah, good point. Thank you for mentioning that. Overall, actually, one thing I'm going to talk about is, you know, there were like I talked about the scientific goals of the experiment. But for me, another one that was in the back of my mind was seeing how, you know, we could use amateur, and, you know, I don't like the term amateur because Jim is no amateur, but use, I guess, civilian or volunteer astronomers to help this sort of research. And we did, you know, DRDC did go into a contract with Jim to financially compensate him for the work that he did for us. But this experiment was a nice example, a successful example of how, you know, when we don't have the sensors to do an experiment, we could potentially look to, you know, a community like yours to help support us to achieve our goals. So with that regards, I think that experiment was highly successful, and, you know, one that I might hope to do again in the future if, you know, this type of event occurs, and, you know, services like this are needed. So with that, thank you very much, and the floor is open for questions.
Great, thanks so much. Questions for Don or Jim? Just don't forget to unmute yourself, because everyone's pretty much muted otherwise.
Did you get all of the data that you were hoping to, or would you have preferred to acquire more data?
That's a great question. You always want more. I always want more data. I think the biggest, well, the issue was weather, right? Was the non-cooperating weather. In our second year, I don't think we used all the funds in the contract, right, Jim?
Oh, not even close.
Yeah.
The second year was the worst by far. Yeah. I think in the whole second year, in that time window, we might have had less than 10 clear nights.
Yeah, whereas in the first year we managed to get all 25 nights that, you know, I had budgeted. So it was, I wish I could have done that, and I wish, you know, I could have, if I could have, this is a contract that I would have liked to kept going for a few more years to just study how that light curves evolves over the year. Other experiments I would have liked to do is, you know, looking at a satellite from Ottawa and from Newfoundland to see, you know, how the light curve should be similar, but they'll be dissimilar in some ways. If we can use those dissimilarities to learn more about the orientations or the characteristics of the objects.
So this isn't something that research that you can carry over into your new role then?
No, unfortunately, in my new role, I'm not going to be a researcher. I'm going to be supporting researchers. They're interested in dark matter, looking for dark matter, and furthering their knowledge of neutrino. Which, I mean, I have an interest. I know at the high level, I read popular books, but I'm there just to manage and support the scientists. Fortunately, though, I am still an adjunct professor at York University, and my plan is to continue working with, you know, the students, or now I call them my colleagues, right, to further this. So if they do come up with ideas, then, you know, hopefully working with their supervisors, I'll try to do experiments like this on a part-time basis.
So perhaps consultant as well with DRDC?
Eventually, I haven't closed the door to that eventually, or who knows, I might return to DRDC. This is something I wanted to try. I live in Kingston and I worked in Ottawa, and, I've been traveling back and forth, and I just wanted to find something a bit closer to my home. So, but who knows, I may want to go back to DRDC and be a scientist, just a scientist once again in a few years. So.
Yeah.
Any more questions? I was either very boring or clear as crystal water.
I have a comment, not a question. First of all, thank you, Donald, for your very interesting talk. I'm Dave Chapman. I'm a retired defense scientist. I worked at DRDC Atlantic, and I retired in 2008. So I'm enjoying my retirement.
Oh, good to meet you.
You mentioned it, you were reluctant to use the word amateur, but I just wanted to jump in and say that in both English and French, the word amateur is based on the Latin word for love, and that an amateur does it for love, not money. Okay.
All right. Well, I won't say that comment anymore. I meant it when I guess I talked to colleagues. They say, "Oh, someone who's not a professional," but so that was the I guess what I meant to say. I mean, yes, but no. Thank you very much for that clarification. It's appreciated.
I've always felt that way about the term amateur, and anyway, it's just one of my my things that I like to point out, the root of the word.
Oh, that's great. No, I learned something today, so this is good. Thank you.
So hence be proud you're an amateur. Any other questions for Don or Jim? Okay, I just want to thank you both again for coming today. This has been fabulous. I've been waiting a while for this. I know that we've all been looking forward and waiting for September to hear from the both of you. So thank you so much for attending today. Very much appreciated.
Thank you for having us.
Yeah, well, thank you very much. I won't stay for the remainder of your meeting. I've got 3 kids and it's super nice in Kingston. So I think we've told them we'd go to the beach. So with that, thank you for having me. And Jim, it was nice to see you again.
Yes, you too, Don. Would you like some hurricane weather?
If I'd like, oh, I'll pass on that. I got a lot of housework to do. So
Jim, some rain here would be very nice.
Yeah, well, we can send you some. We're going to have 100 millimeters in the next 2 days. So
we don't need 100, but some of that would be nice.
Hey, like Don, I'd like to thank you guys for having us. I'm going to have to excuse myself from the rest of your meeting as well, but it was certainly a pleasure.
Thank you so much.
Thank you.
Have a great day.
Enjoy the rest of your day. Okay. I know that next on our agenda, we had Dave Chapman doing What's in a Name, but before we have Dave, we have another Dave. So Dave, we have David Hoskin. One of the things that we had done traditionally, and I apologize for not having included on the agenda, was the photo montage. And David Hoskin has prepared one. So perhaps Mr. Chapman, as a precursor, if you will, to your presentation of What's in a Name, we'll have this other presentation, and then you can take it from there. How's that?
Sure, I'm ready to go. So, but if David is, let's go.
All right. Mr. Hoskin, you're up.
All right, I'll share my screen. Where's it?
There we go.
Okay. Hey, can everyone see that?
Yes.
Perfect. All right, so what I've done is I went through the RASC Halifax Facebook post over the month of August and just pulled out some of the work that the different imagers in the center have been doing, and just run through them. So we start off with Mike Boschat, and As usual, he gets wonderful pictures, just aiming a camera and his telescope through a window. Pretty impressive. This is from Nova East. I think Jerry Black took this one. See the cunning fluorescent tape on his telescope mount, lighting it up. This was Brian Smith. A sketch by Dave Chapman of a large sunspot group that he did at Nova East. Jerry Black's Crescent Nebula. Jason Dane has been very active. He tried to capture some northern lights in August and was able to get a little bit. August wasn't as good as earlier in the year for northern lights at our latitude.
Nice reflection in the water, though.
Yeah, very nice. Michael again, hydrogen alpha of the sun. This prominence is quite impressive. I think that it's, sorry, not prominence, filament when it's seen on the disk of the sun. I think it was like 400,000 kilometers long, so huge. Grav Singh's starless M31, Fabius and Tycho craters I took early August. Jason Dane again, solar image. Jeff Donaldson, North American Nebula, and what some people are calling the Deadpool Nebula.
And the Pelican.
And the Pelican. Fiona Morris. Fiona didn't do too much, but she did this spectacular one in August of Stefan's Quintet and the Dirichlet group of galaxies. Amazing work. Jason Dane again, Squid Nebula. I forget how many hours he put into this, but it was a lot. Blair, Bubble Nebula, taken from his cottage. This, I believe, is Kathy Walker. Yep. Solar image I took at Nova East. This is a really nice prominence. Lisa Ann's also been doing some solar imaging. She captured these nice gossamer-like prominences through her scope. Jason Dane, another gorgeous Milky Way image from Jason. Michael Boschat again, white light solar image, again taken through a window in his apartment building. The Lagoon and Trifid Nebula, I took at the York Redoubt a week or so ago. Blair again. Yeah, this is, never heard Pickering's Triangle, I think. I hadn't heard that phrase to describe this part of the Veil Nebula complex. Kathy Walker doing some reflection nebula. Lisa Ann Fanning with a nice high resolution image of the moon just after first quarter. Jason Dane, again, with a nice bright emission nebula. I took this picture of Saturn. Scene wasn't very good, but hoping to do better at some point. Blair, the Elephant Trunk Nebula. He's getting some really nice images when he goes up to his cottage and the weather cooperates.
That's Cape Breton way in the dark.
Yeah, dark does help.
Yes.
Another Bubble Nebula by Kathy Walker. I love how she brought the blue out.
Mm.
A white light image of the sun, the whole solar disk that I took again at Nova East, and I used a Herschel wedge to capture this rather than a front filter. Blair doing the Crescent Nebula, and Kathy Walker. This is I think it's a Ghost Nebula, and that's it.
Thanks, David. There's some impressive astroimaging in this center. And many of it from suburban skies, which I always have to chuckle when I hear from other centers saying you can't take photos from the city. And I'm going, come visit us, we'll show you how. Yeah. So thanks for that. Which then leads us to Dave Chapman. Dave is a former observing chair and, well, longtime observer. And Dave has a section in What's in a Name. And so, Dave, I'll let you take it away.
Okay, can everyone hear me and see my slide?
Yes.
Okay, thank you. Okay, so this is the third installment of What's in a Name. The first one had to do with asteroids, and the second one was comets. And so for the third one, I decided I would talk about the names of the natural satellites of the planets. And I have to tell you, I didn't realize how much of a job it was going to be. I thought this was going to be pretty straightforward, but when I got into it, I found that it got quite detailed, and it took me a lot longer than I thought. So anyhow, let's get started. So the people that are in charge of naming things in the sky is the International Astronomical Union, and in particular the Working Group for Planetary System Nomenclature. And so they sort of decide on the names of planets and dwarf planets and minor planets and so on. And they also are in charge of naming the satellites of all of the above. And just to include a bit of history here, the term satellite was introduced by Johann Kepler in 1610, shortly after Galileo discovered the four principal satellites of Jupiter, and it was Johann Kepler who said, you know, we should call these satellites. So that's the official term. A problem is, of course, that people started using the term satellite for spacecraft that went around the Earth. And they were calling them artificial satellites, but then that got dropped, and people were just talking about satellites. So now when we talk about the natural satellites, you have to specify. And this was brought home to me one time. I was showing someone in the telescope. I said, "Oh, this is Saturn." And that dot to the next to Saturn is its principal satellite, Titan. And the woman said, "A satellite? You can see a satellite from that far away?" And then I realized that she thought I meant a spacecraft. So these days we use the term natural satellites. I was told not to use the word moon for these objects, but it's becoming more acceptable to call these moons. Anyhow, let's move along. Okay, so how many natural satellites of the planets are there? Well, I had to get the latest from James Edgar. I think I got him to send me the latest handbook version. And to date, there are 205 natural satellites of planets. They're not all named. That's quite a lot. But most of them are belong to the outer planets, Jupiter, Saturn, Uranus, and Neptune. But dwarf planets also have satellites. Like, for instance, Pluto has 5, and minor planets have satellites too. And I apologize for not including Pluto in what is coming. I apologize a little bit. I decided to limit it to the planets because I got so tired by the time I got to Neptune, I just couldn't do any more. So I just said, okay, I'm going to stop with Neptune. I'm not trying to ignore Pluto. Pluto is an important dwarf planet, and it has quite a few satellites, but maybe I can cover that another time. So in order to understand what comes, you need to know the very basics of the Greek god family tree, because a lot of the satellites are named after Greek deities. So, and I tell you something, this is very complicated when you get into the details of it. This is like a very oversimplified overview, but you need to know this to get what's coming. So the primordial deities or gods are two. Gaia, which is earth, and Uranus, which is sky. And the RASC motto is Quo Ducit Urania. So where does Uranus lead? So that goes back to the to this primordial god of the sky. And they gave birth, the next generation of deities are the giants and the titans. So these are names like Cronus, Oceanus, Hyperion, Rhea. We don't tend to know much about the titans and the giants. Most of our attention in Greek mythology is focused on the Olympian gods, Zeus, Poseidon, Ares, and so on. They're the third generation of deities. After that, you get minor deities, nymphs, mortals. But if you look at the whole family tree, it's immense. Okay. Now here's the curious thing about nomenclature. For some reason, we use for most cases we use Latin names for the planets. So things like Mercury, Venus. I'll skip over Earth, Mars, so on, Jupiter, have Latin names, but the satellites mostly have Greek names. So that makes things really confusing. So you need to know, in some cases, the Latin and Greek equivalents of some of these gods. So you didn't realize how much culture there was going to be in this. So let's just move on, and let's dispense with the inner planets. Mercury, which is in Greek god Hermes, has no satellites. Venus, which in Greek is Aphrodite, has no satellites. Earth, which is named Terra in Latin and Gaia in Greek, has one satellite called the Moon in English, and that derives from the German word Mond, and that's also the root of the word month. But in Latin, it's Luna, and Selene is Greek. And I just threw this in for fun. Both Artemis, how do you say that? Artemis and
Artemis.
Apollo. Artemis and Apollo are female and male twins, and they are deities associated with the moon. And I threw that in. It doesn't really matter for what comes, but I just thought we've been talking about the Artemis mission and the program coming up, and I just thought, I was wondering whether people understood the importance, what the significance of using the term Artemis is in relation to Apollo, because Apollo, of course, was the last program of moon landings, or the first and last, and the ones to come are going to be Artemis. So I just thought I'd throw that in as a side, and it comes from the Greek again. So Mars. Now we get to some other satellites. So Mars, or Ares, is the god of war in Greek mythology, and Mars has two satellites, Phobos and Deimos. One is the god of fear, and one is the god of dread, and they're the sons of Ares and Aphrodite, and they're sometimes depicted as charioteers. So that is the connection between Phobos and Deimos, Mars and Aphrodite. I did not know that. We often hear Mars and Venus mentioned together. Men are from Mars, women are from Venus, that kind of thing. And they're often mentioned together. They are the two planets the closest to Earth, interestingly enough. And so I thought it was interesting that the satellites of Mars are essentially the sons of Ares and Aphrodite, and of course Phobos is the root of the word, you know, phobia, of a god of fear. I couldn't think of anything for Deimos. If anyone has a suggestion, I'm open to it. Now we get to the really fun stuff. Jupiter, Zeus, the king of the gods. And so I mentioned that Johann Kepler introduced the term satellite, but the names for the Galilean satellites were suggested or named by an astronomer named Simon Marius. Those names went out of favor for a while, but they came back in and are now the official names of the 4 Galilean satellites. And so this page is rated PG-13 because I had a long discussion with my wife about how much I should say about this. But basically the theme with Jupiter is that all of the satellites are named after, let's call it the extended family of Zeus. So his wives and his children and his other consorts and various individuals that he spent time with, let's say. Okay, so I don't want to go into any more detail. So Io is the priestess of Hera, which Hera is Zeus's wife. Europa was the queen of Crete. Zeus, by the way, was brought up in Crete in a cave. There's a long story about how he had to be hidden from his father who wanted to kill him. So anyway, Ganymede is a male figure who is the cupbearer of the gods and was quite adored by many. Callisto is a nymph who was a hunting companion of Artemis. I haven't actually figured out what a nymph is. I'm not sure if they're immortal or mortal. I didn't get enough time to really sort of drill down and figure that out. Then there's some inner satellites, Metis, I guess, Adastria, Amalthea, and Thebe. And again, these are, Metis is a Titan, first wife of Zeus. There's a couple more nymphs. So Adastria was a nursemaid to Zeus, and so was Amalthea. Thebe, not quite sure about Thebe, but was some kind of consort of Zeus. So you can see the theme here for Jupiter is that it's all related to him, the king of the gods, and so on. And now we get to some of the weird satellites. So the regular satellites are orbit in the of any planet. The regular satellites orbit in the plane of the equator of the satellite, and they're very intimately connected with the primary in a gravitational sense, and are often tidally locked. The irregular satellites have orbits that are all over the place, all different inclinations, and some of them go from the point of view of looking down, considering the spin of the planet. They're prograde. In other words, they revolve around the planet in the same direction of the planet's spin, and other ones are retrograde because they go backwards. And the IAU has decided that the irregular prograde satellites would be all names ending in A. So Himalaya, Elara, and so on. So there are nymphs, lovers, a lover, it goes on. The irregular retrograde satellites of Jupiter are all names ending in E. Carme, Ananke, and so on. And they both bore Zeus' daughters. So you get the drift. So, and it goes on. I can't remember how many I said. Was it 72 for Jupiter, or even more? Anyway, you couldn't. They're not all named, but there was just too many to go through. But you get the drift. Saturn is Kronos in Greek. So Jupiter was an Olympian god, but Kronos was the youngest of the Titans. So it's like the previous generation. And the regular satellites were named by John Herschel, And they're all names of titans, other titans and giants, and so on. These are all regular moons, and 1, 2, 3, 4, 5, 6, 7, 8. They're all observable, although Mimas is very difficult. But in the handbook, those are all the regular moons are considered observable. Then there's a whole slew of moons that are associated with the rings. There's a few moons that are co-orbital, like they have the same orbit, but they're in different positions in the same orbit. And then there's some ring shepherd moons and then ring gap moons. It's quite complicated, but they're all basically titans or giants in name. And then when it comes to the irregular satellites, I guess the IAU just, they gave up. There weren't enough titans to cover all of the satellites, so they came up with a new scheme of things. So the irregular prograde satellites. They boil down to two groups. There's an Inuit group with names like Kivink, Ijarik, Paya. I have never heard of these before. I don't know much about their character, and then there's a Gallic or Celtic group, Albiorix, Bebion, Iria. Most of these are pretty recent, like in the last few decades, because they're very difficult to see these small. They're basically like captured asteroids or little chunks of rock. And they keep on discovering new ones all the time. And the irregular prograde, retrograde, have the name. Well, there's one that's kind of a little bit. Phoebe is a Greek titan, so that's kind of stands out there. But I guess that's when they've ran out of titans, because the next group is the Norse group: Skathi, Skol, Hyrcan, so on. So all of the subsequent satellites will fit into one of these categories, one of these groups. Anyway, I was getting pretty tired by this time. Then I had to do Uranus. Uranus has a few enough satellites that I can't name them all. But there's the inner moons. Now this is interesting because a couple of reasons why this is interesting. Uranus is obviously a proto god, a primordial god, the god of the sky, and in this case, for some reason, the people who decided to name the planet decided not to name it by its Latin equivalent. And the Latin equivalent is, was it Caelus? I can't see my own screen here for some reason.
Aelus?
Yeah, Caelus, yeah. So that's where the word celestial comes from. For some reason that I couldn't find out, they decided to stick with Uranus, the Greek name. So there you go. You have a rule and then you break it, okay? Now this is very interesting because all of the satellites, natural satellites of Uranus, and the first ones were named by John Herschel, the son of William. And he came up with the idea of naming them after characters in Shakespeare plays. So the first ones that were seen, 1 through 5, so Miranda, Ariel, Umbriel, Titania, Oberon, these are, I would say, observable, although you have to have a pretty good telescope to see them. But he decided that they should be named after Shakespeare characters, or there was a poet by the name of Alexander Pope who wrote a satirical poem called The Rape of the Lock. Now, before anyone gets upset about that, this is the use of the word rape here does not refer to sexual rape. It has to do with the idea. The story basically was somebody had to surreptitiously cut off a lock of somebody's hair and run away with it. Okay, so he wrote this poem and it's called The Rape of the Lock. And so there's a couple in here that are named from characters in that story, but these large moons are from The Tempest and The Midsummer's Night's Dream. The inner moons are names like Cordelia, Ophelia, Juliet, Portia, Cupid, Puck. Any Shakespeare scholar out there might be able to recognize, but there's multiple Shakespeare plays that are represented there. Hamlet, Romeo and Juliet. What's that one? Merchant of Venice. Merchant of Venice. More Midsummer Night Dream. Anyway, it goes on and on. Too many. And then we get to the irregular satellites, and there's only one in Uranus, the case of Uranus. It's called Margaret, and it's a character from Much Ado About Nothing. And then the retrograde irregulars are all from The Tempest. So Francisco, Caliban, Stefano, Trinculo, Sycorax, Prospero, Setebos, and Ferdinand. So pretty cool. Finally, well, almost finally, Neptune. Poseidon is a god of the sea, the Olympian god of the sea. And all of the, he's god of the sea. So all of the lateral satellites of Neptune have to do with some water deities, mostly minor. So Naiad is a freshwater nymph. I didn't realize that they distinguished freshwater nymphs from sea nymphs. And then there's nymphs which are nymphs of like creeks and that kind of thing, and fountains. So and Thalassa is a sea goddess. Despina is a goddess of frost. She was the daughter of Poseidon. Galatea, sea nymph, and Hippocamp, hippo, horse, sea horse. Proteus is a sea god. And then Triton and Nereid they're irregular moons, but they're very special. They don't seem to behave like other irregular moons. Triton is, for instance, is huge, and it's round. It's a huge moon, and so anyway, it's named after another sea god, Triton, son of Poseidon, and it's believed that it's a captured dwarf planet. And Nereid is special for a reason I can't remember, and it's also a sea nymph. And then there's one prograde irregular, which is a sea nymph. And then there's some retrograde ones, which are, well, you see the names there. I don't recognize these names. They're all pretty recent. Halimede, Sao, Samphe, and Naso. Anyway, I've got all of the satellites of Neptune there. So you can imagine how much work this was. It was like, I couldn't believe how many details there were and all the things I had to look up, to sort this all out. I almost regretted taking it on, but I'm glad I did it. Now, as in previous presentations, I wanted to talk about how provisional satellites are dealt with. They still keep on, mostly in Jupiter and Saturn, they keep on discovering new ones. And they're given temporary names, provisional names. So it starts with S for satellite, the year of discovery, the first letter of the planet name, and then the order that year. They don't discover them that often. So I looked back, and the most recently discovered unnamed satellites are S2017J3 and S2019 S1. So they're only a few years old and haven't been named. Now, how do they get a proper name? Well, the discoverer of the satellite can suggest a name, and then it has to be approved by the IAU working group. So anyhow, that is the presentation about the names of what's in a name, the natural satellites of the planets. And I'm open for questions or comments.
First of all, thanks, Dave, for the presentation. It's interesting how they interchange the Greek and Roman and whatever else source for the names on these. They seem to be consistent in some areas, but not so consistent in others.
Well, thanks for noticing that. What I left out is the history of, in almost every case, the names evolved and changed, and there were arguments about them. So I'm just telling you how things ended up. So there's this whole deeper history of arguments about names of planets and satellites that you could get into. One could write a book on it, but I think it would be rather boring. Maybe you could make it interesting, but it involves history and personalities, and yeah, it's kind of like a bottomless pit when you get into this. I'm going to pick something easier next time.
Dave, this is Terry from Pennsylvania.
Yeah.
I don't know that you intended to, but I think you answered a question that I've had for a long time.
Okay.
My question was this: when does a moon turn into just a hunk of rock? In other words, how small can it be and still be considered a moon? Well, I guess if we ignore that term moon and go to satellite, it can be any size.
I think the IAU officially uses the term natural satellite. Moon is used generically. I don't think there's any real distinction between a moon and a satellite. In other words, officially, I don't think the IAU makes discriminates between them. Almost all of these recently discovered satellites, especially the irregular ones, they're almost all captured asteroids, but it's not clear. I mean, when you get into Uranus and Saturn with their ring systems, I mean, you could say, like, is every piece of dust in a ring, is it a satellite? You know, so it gets very complicated in there. So I don't really know how they determine, you know, what is a satellite and deserves a number or a label as distinct from, you know, just junk orbiting around. So there must be some. It's like what distinguishes an asteroid from a meteoroid. You know, how small does an asteroid get before it's just a meteoroid? You know, it's the same kind of question, I guess.
I have seen a definition for that. I'm not sure I remember correctly, but it was either 1 meter or 10 meters.
Okay. Yeah. So there's kind of a roundabout way of explaining this is to declare that there is a satellite, you have to make an observation of it. And these little hunks of rock are pretty dim, and they need to be discovered by things like the Hubble telescope and other large telescopes, or by flybys. There was a ton of satellites that were discovered during the Voyager flybys, and there was a big rush to, you know, sort that all out. But these days, they're awfully dim, and so you have to be able to make a measurement and compute an orbit for a specific thing. So much in the same way as for a minor planet or a comet, I guess. You have to be able to determine an orbit, you know. Okay. So then maybe that's the answer.
Thanks, Dave. We're going to close the questions at this point, but I'm going to make a comment that came from Rob Fanning. He says, we really enjoyed this. And by the way, the Giants are playing the Titans tomorrow in football.
Oh, that's interesting, because they're the same level of, same generation of, interesting.
Yeah.
Well, the Giants and Titans were known for having battles. So there you go.
There you are. Okay. So we have David Hoskin back again in his role as our observing and outreach chair to give us what's up in the September skies. We're a week into it, or a little better than a week into it, Dave, but I'm sure there's still lots to see up there, yes?
Certainly is. Let's go to my screen. What's going on here?
It says end of slideshow.
Right. So,
there we go.
Okay, see that. Good. Okay, so what's up? Well, lots still. The sun this month, days are getting shorter again, so we have more night time skies to enjoy. Sunset at the start of the month was 7:50, and by the end of the month, it'll be almost an hour earlier, 6:56. giving us with dawn at 5:34, giving us 9 hours of darkness. And so that's nice. In terms of solar activity, the sun's was pretty active up until about a week ago. There's lots of sunspots around, but they're fairly small, and there haven't been any major flares. There've been a few small B and C class flares. There has been a lot of activity on the far side of the sun. So if the sunspots that are responsible for the various flares and coronal mass ejections on the other side of the sun are still intact when they turn around to face us, we may have some more exciting things to see. The moon, we're at the full moon, the mate calling moon, Wigunge we goose. We missed some conjunctions. After the first quarter on September 8th, we had a gibbous moon and Saturn nearby. September 11th, we've got the gibbous moon and Jupiter. So that's tomorrow, and that's a nice binocular view. If you have a fairly wide field of view, about 7 degrees with binoculars or a wide field telescope, that's what you'll see. Quite nice. September 17th, we've got the gibbous moon and Mars fairly close together, and then September 20th, last quarter, and new moon at the end of the month, September 25th, and that will be the start of the animal fattening moon. Explore the universe, or to check these boxes off in your explore for the moon and explore the universe. Again, as always, the best dates are around the first quarter, fairly early in the night, so you don't have to stay up late. If you're an early riser, you could wait till the last quarter and check some of these off. So you need to observe 3 craters and 3 mare in binoculars or with a telescope. And the reason for choosing around the time around the first quarter and the last quarter is that's when the terminator is bisecting the moon, and you get lots of shadows. So first quarter, you'll see a lot of stuff on this side, and last quarter, you'll see stuff on this side. Planets this month, they're all visible. Well, unless you saw Mercury early in the month, you've missed the boat. The inferior conjunction was on September 2nd, but if you had a very good western horizon at the start of the month, you might have spotted Mercury very low. Venus is low in the morning twilight sky at the start of the month, and by mid-month will be very difficult to see. Mars is coming into its own. It rises now before midnight and becomes quite bright. It's close by the star in Taurus, Aldebaran, which is also a red star, and the two together look quite striking, a brighter and a somewhat dimmer red object. The next opposition, which is coming up when Mars is closest to the Earth, will be in December. Zodiacal light is visible in the eastern sky now before morning twilight. The best time to look is between the 23rd and the 30th of September. during the start of the new moon and when there's no other moonlight to obscure that very faint triangle of light. Jupiter is visible all month through, so it's all very bright, magnitude -3 all through September. Its opposition for Jupiter is on September 26th. So if you're interested in planetary imaging, assuming clear skies, that's a good time to point your telescope and camera at Jupiter. Saturn rises just after sunset, and as with Jupiter, it's well placed to observe throughout September. Uranus rises in the east in the late evening, and so is visible with a telescope. And Neptune is in opposition in northeast Aquarius on September 16th. So the end of next week. It's even at its brightest, it's only magnitude 7.8, so not visible to the unaided eye, and a very small disk. But again, the best time to see and image Neptune if you're so inclined. Autumn constellations in Explore the Universe: Pegasus, Andromeda, Cassiopeia, Perseus, and Aries are all visible in the eastern sky after sunset. Autumn stars, some key ones: Mirfak in Perseus, and Algol, also in Perseus. Is a variable star, sometimes called the demon star. Shedar in Cassiopeia, Markab in Pegasus. The stars marked with N are stars that show up if you have a SynScan controller for your telescope. Those are used as navigation stars. So it's good to know where those stars are found. The autumn deep sky objects, there are 3 in Explore the Universe for you to check off over the next few months: Andromeda Galaxy, the double cluster, and Lot 20. For this month, see if you can see the double cluster. It's visible from a dark site with the unaided eye. Quite stunning in binoculars and with a wide field telescope. So that's an easy one to check off, and you don't have to stay up too late to get it. I'll be highlighting Lot 20 and the Andromeda Galaxy in subsequent What's Up. Autumn double stars. There's only one autumn double star listed on Explore the Universe, and that's 16 Cygni A and B. You can find this double star pretty easily. Identify the constellation Cygnus, which is currently pretty high overhead near the zenith after sunset. And if you can find Iota and Theta Cygni, 16 Cygni A and B are just nearby those 2 stars. They are both yellow dwarf stars, about 69 light years from Earth. And interestingly, an exoplanet has been identified orbiting 16 Cygni B. Now, I don't have any pictures myself of this particular double star, so I took this picture off Wikipedia, but they're a pretty easy double to split and quite nice. Nice bright yellow stars paired quite nicely. And that's it for What's Up in the September Sky. Are there any questions?
Thanks, David. Any questions for Dave? No, I think it'll be interesting to see some of the things that you had mentioned. The not conjunctions, but the ones where the planets are in close proximity to the moon within
Mhm.
an FOV. Those will be interesting to see if we can actually have clear skies enough that we'll be able to.
Yes. Yeah, I think the Jupiter one tomorrow will be
Yeah.
because Jupiter's so bright, the moonlight's not going to wash it out at all, and it'll look
Yeah.
quite nice.
Yeah, lovely. Thank you for another interesting episode, and we'll look forward to next month as well. So thanks. I guess I have to share my screen now because what's new from the board is the update. So again, I'm Judy Black, the president. You can reach me at that particular email. And it's been a tradition for quite a few years now that we provide an update with what's been happening, not only with us as a center, but also some of the features coming up from National as well. First and foremost, the Halifax Centre stars. Jason Dane has this emission nebula posted as the astronomy picture of the day back in August 1st of 2022. It's a rather interesting nebula by the look of it. Also, Silas Eastwood, who's a youth member, he won the RASC Intermediate Prize in Astronomy this past June. And look forward to hearing from this youngster. We have him agreeing to present his project at our January meeting, so you can look forward to that. Hassan Ali, he also has a space radio show, and he's been posting in the discussion listing for our center with his particular podcasts, and I'm hoping to get him to come to it as well, that particular session in January. Sky News, Photo of the Week contest, the runner-up in the youth category. Guess who? Fiona. She won, she took this. First of all, it's a North American nebula, and you can see part of the pelican in the picture that I think, David, you pointed out is the other one with the two eyes. This part of it in here that you labeled.
The Deadpool Nebula. I think
That's it.
John
Yeah.
Reed refers to it as that.
Well, I can see why, but yes. But she took that picture back in June of 21 using those particular pieces of equipment and the 50 minutes time-lapse time. But she has won the runner-up for the youth category. So congratulations, Fiona. Another job, very, very well done. Also, there's a letter to the editor, a 2-for-1. Dave wrote the letter, and Jerry's photograph taken that particular weekend that we were in Kejimkujik Dark Sky Preserve for a week, a couple of days of camping. Very interesting week. Alan, as Dave says, Alan Dyer's 15 top 10 targets. Because although he listed top 10 targets, there were actually 15 items to look for. So that was an interesting weekend to do that. Also want to remind folk, and Lisa Ann, perhaps you can provide a date. I apologize. I did not get a date by which you want people to provide their input onto the next edition of the newsletter.
That would be October 2nd.
All right, we will make note of that. So that is Saturday, October the 2nd. Sorry, Sunday, October the 2nd. If you have articles of any sort to submit for the next edition, but currently volume 53, number 3 is online, and you can see the cover there. I believe that's David Hoskin's photograph that's there, but there's all sorts of really cool stuff inside that latest edition. So if you haven't read it, please do so. And Nova East, for those of us that attended, it was a huge success. Lisa Ann, you can see your hard work put on people's chests. It was wonderful to see all those t-shirts. Unfortunately, there were a couple of people missing. There were actually 47 people in attendance, and not all 47, unfortunately, were in this photograph. But what was really wonderful was the international community that we had in attendance. Not only did we have Nova Scotians, but we had people from the US. Matt Payne from Massachusetts was there, but we also had 2 recent immigrants from Lebanon attending our session. So we were thrilled to have them. I want to thank the Nova East Planning Committee, my fellow members, Greg, Lisa Ann, Paul, Melody, Pat, Tony, Jamie, and Chris, for their support and hard work over the past, since January, to put this session together. I think everyone had a phenomenal time at it, and lots and lots of time for being together again under the stars. It was just wonderful. And also thanks to our presenters, as you can see there, and to Tony McGrath for organizing the flea market. And I also want to thank Saturday night's storytellers. We had a session, an informal session, in which we, those in attendance, described their oh wow moments, everything from the Southern Hemisphere to the Northern Hemisphere, national parks, including, I think it was Matt who described being, realizing they were completely surrounded by a herd of buffalo in the middle of the night. So it was really lots of fun to hear those wonderful stories. And thanks to all the volunteers who weren't mentioned here, but did make the contribute to the weekend. Oops. And for those of you that still haven't, I know that some of you have photographs that were taken that weekend and they haven't been passed on to Jerry. Please do so, 2 meg or less, so that we can post them onto the website, and other people, the members that were there, can certainly enjoy reliving some of those memories, and those that weren't in attendance could see some of the fun that we've had. So please do that soon, and Jerry will get them posted. I also want to thank Jason Dane for his fabulous work in the inaugural Sherman-Williams Walk, the birding at Smiley's. You can see Jason there with his arm up, and that's only a part of the group that I was able to capture in that photograph. But Jason pointed everything from the forest floor up to the treetops, even encouraging birds to come so that we could see some of the birds that were actually in the forest at Smiley's. It was a wonderful afternoon in the woods at Smiley's. So thank you so much, Jason. As Melody said at one point, I'm sure that Sherman would have enjoyed it. Tarek, who was one of the 2 individuals I mentioned who had recently immigrated from Lebanon, took this field of the observing fields before the clouds came. And of course, what would Inova East be without an inauguration of yet another Dave to the Royal Astronomical Society of Daves? So Dave the 38th is in the center between Dave 17 or 18 rather, no 17 Chapman and Dave 8 Lane. So congratulations to Dave Robertson, number 38. Also, the Dark Sky Weekend. I want to thank Peter Hurley and Tony Schelling for a job well done in organizing this. And to the park staff, I apologize. Perhaps Peter can name the other park staff. The only one I can remember is Colleen. But it was a phenomenal 3 days down there. 2 of the 3 nights were absolutely incredible. The volunteers are listed there. You can see them. We had young and old alike contributing, volunteering at the binocular table, and also, as you can see here, providing access to their telescopes and whatnot through EAA, which is Electronic Astronomy Assistance or something, Electronic Assistant Astronomy. Anyway, and you can actually see down here. Anyways, this is facing south, obviously, because there's the Milky Way, but it was a really great weekend. There were about 925 direct contacts with the public at this particular session, so it was absolutely phenomenal with the numbering. So congratulations to Peter and Tony and to the park for a job well done. Our meeting dates, our regular meeting dates, our next one is October 1, November 5, and then December 3rd is our members meeting plus the AGM. For now, it's still Zoom. I have been trying to poke the work group to get it going so that, fingers crossed, maybe October 1st, but hopefully by November 5, we will have the hybrid meeting so that those of you that are from afar can still see what's going on through Zoom, and those of us that are closer and want to attend in person can in fact do so. Again, we ask, if you would like to contribute to the meetings, they don't have to be 45-minute presentations. They can be just a simple 5 to 10, if that. What astronomy gear have you recently acquired that you are really pleased with or utterly frustrated with that you'd like to point out, and why? Read a good book lately you'd like to pass on? And what about sharing observing strategies? The oh wow and the uh-oh moment. Do you know of a speaker to invite to our sessions? We'd love to hear from you. Also, special events. Mark your calendar, please. Our annual school barbecue and observing night is Friday, September the 23rd. Rain date on the next night. It starts at 5:30. We hope to have a good sized crowd out there this fall. Keep in mind, because it is September, it gets darker sooner. There are fewer flies, even though you might still want to bring your fly dope and your tick repellent. Nonetheless, we will be providing observing following the barbecue as it darkens. So members are welcome to not only to eat, drink, and be merry, but also to stay for the observing side of the evening. For those folk that are actually out at SCO observing or whatever, could you please make sure that any paper products or anything that could be utilized as nesting materials by squirrels or other smaller rodents is put away, okay, so that they don't have access to it, because we are finding evidence, for instance, of them using a toilet paper roll that was left out as part of the nesting material. So just keep that in mind when you're out there. Thank you. Also, the RASC calendar order. In years past, we have purchased a bulk order of calendars and we've sold them at our members' meetings. As you can appreciate, that isn't going to happen this year. So consequently, the board at our meeting on Tuesday night decided we were not going to have a bulk order of the calendars. But and right now they are only available for bulk ordering. But if you wait till October, they are supposed to be available to members. So you'll have to order your own calendars this year. And we're sorry for that, but circumstances being what they are, one, we're not meeting face to face necessarily. And secondly, volunteers to mail things out is getting more challenging to find. So for those two reasons, we're asking that members acquire their own copy. And we certainly need your help. As you've heard us say before, COVID certainly had an effect not only on us, but every center. We've hadn't had any face-to-face since March 2020. There's limited or no public outreach, although that is climbing, which is good. We're unable to meet new members face-to-face. We're unable to reconnect with returning members, although these latter two certainly are improving, but they're certainly not up to the prior standard that we had. And this is certainly true. The knowledge of interest and expertise of members are not really known. It was in the face-to-face that we actually got to talk to you folk, meet you, and got to hear what turned your interest into astronomy or other things, even outside of astronomy. So those pieces of the puzzle were missing for us. So we need you. Why? Well, we are a center that is of, for, and by the members. You got to remember that, yes, there is a board and we're hoping to direct things, but it's what we, and the we, I don't mean just the board, I mean you as well. It's what we all make of it. Okay, so we all are important to it and we all make it happen at various degrees of happening. So we'd like you to be part of the team. It's fun and rewarding. There's all sorts of neat stuff. Your participation and input are needed. And you can be in the know that way. Get to know each other, meet new people, learn new skills, and really importantly, prevent that volunteer burnout. Because as you can appreciate over the last 2 years, there's been a core of people, and God love them, they've been doing a fabulous job, but we would also like to involve more people. More hands make light work after all. Everyone can learn new skills, and the mentorship side of things. You can be one, or for newer members, even find one. The nominations for the new board, for the 2023 board, are coming up. All nominations, now keep in mind, nominations are open until they are closed at the AGM itself. However, our bylaws do stipulate that 20 days before the AGM, the announcement of all the names for each of those positions on as far as directors and the president, vice president, treasurer, secretary, and the 6 directors have to be circulated to members. So if you're interested, even just have a question about any one of those positions, please contact Peter at the generic email at secretary@halifax.rasc.ca. And we do need to know that before Saturday, November 12th, because that's the 20 days before the AGM, believe it or not. The two that are highlighted in green, unfortunately, those two individuals, me as president and Greg Dill as treasurer, are unable to run for another year because our 5 one-year terms are up. As you can appreciate, without a president and without a treasurer, this center would not function appropriately. So it's really critical that we get people to step up to one of those two roles. Now, what's interesting about the treasurer position is that in talking to Greg, he agrees that if someone could take it for a one-year term, he would be willing to come back in 2024 because he truly did enjoy the role. But because our bylaws stipulate he has to step down for a minimum of 1 year, he cannot run again for this coming year. So if someone can take it on for a year, mind you, Greg has not gone away. He's certainly there for consultation and whatever you need it in that role. But it would certainly be helpful if someone could step up to one of those two positions. The others are not highlighted so much because they can still run for those positions. But if you are interested in one of those, just think we could actually have an election. Woohoo! Wouldn't that be interesting? So if anyone across the center is interested in any one of those positions, please give Peter a call or an email. And also, as I said before, if your meetings, for our meetings, if you have a topic or book review, equipment review, observing strategies or fiascos, good observing sites, the serendipitous observations, the wows and the discoveries, and certainly please do attend in person and or virtually if you can. And maybe even make introductions of speakers at a meeting. We would like to share the responsibility of being the host for the meetings, although I have been doing that for many years now. We have a thought that perhaps we could rotate that through a few people throughout the year. So if you don't have to make a presentation, you just have to introduce people, and certainly we would give you the materials in which to introduce each of the speakers involved. So that would be helpful as well. So any way that you can help the center would be more than welcomed. Task teams, subcommittees, it is fun. Yes, it's work, but there's always laughter, because without laughter, none of us would be staying in the roles that we have on these committees. And I'm sure those of you in attendance can attest to that. We would need new membership of the Nova East Planning Committee during the Dark Sky Weekend planning. Peter would be involved in that. By the way, there'll be a new Nova East NEPC chair next year. The nominating committee, we could certainly use assistance there, and the governance review committee, if there are souls besides me who take pleasure in reviewing policy, welcome to join us. Also, Peter is asking, and David, I guess, more so, there are two things happening on October 1st at the Discovery Centre, and David, you may want to elaborate on this, but October the 1st is Astronomy Day at Discovery Centre, and there's an activity for about 3 hours in the afternoon. And there's also the International Observe the Moon Night on the waterfront that night. So volunteers are required for both. Am I correct in that?
That's right. And they don't have to be the same volunteers. If there's someone that just wants to do the waterfront activity, bring a telescope along, that's great. Or if they want to help out with the daytime event at the Discovery Centre, just that's good too. We put one on, I think it was August 13th, and it was quite successful. There were over 600 people attending the Discovery Centre that Saturday, and we spoke to, there were 4 of us there, myself, Peter, Jerry Black, and Mike Bochat, and we spoke to well over 100 people who were really, really engaged. So we hope for a repeat performance on October 1st.
Okay, thank you. So, and that's it for what's up from the board, news from the board. Any questions? I'm always grateful that no one has questions. The next thing on the agenda is the newest item that we I mentioned at the beginning of the meeting about, let's talk about. Now, this is something that is open to the floor at this point, in terms of if there's something that you feel members would be really interested in hearing about, or you feel that the center should be introduced to because we should be involved in, or just might like to discuss because it's fun to discuss or controversial to discuss. For example, the announcement regarding the new satellites that are going up that are about the size of a football or soccer field, as an example.
Judy?
Yes.
Yeah, this is Terry again. Does anybody use a logging program, an assistance program called Sky Tools? Okay, I've been using it for about 10 years. Really like it. It does a lot of great things. I saw it advertised years ago in Sky and Telescope magazine. But apparently I've discovered a bug. And it happened so gradually that I didn't notice it. But it has a couple of non-astronomy features, but yet they're important. One, of course, is the ability to back all your data up and then restore it if you have a disaster occur. And another one they have is called Sync. And if you have the program, say, like I do, installed on a desktop and also a laptop, take my laptop out in the field, do my observing, type up notes, what have you. When I come back, I can sync that information to the desktop. Or you can sync both ways if there's a reason. Apparently what I've discovered, because I use Sync more than anybody else, is the bug that it's making duplicate files. And so I was just going to warn people that if you do use Sky Tools, avoid the Sync program until they get the bug fixed, because it's taken my 2,600 and some logs and created 800 and some thousand files over the years. So it's quite a bug, but it did it very slowly and it wasn't noticeable until just recently. So that's all I have.
Yeah.
I guess a related software comment. This isn't about a bug, but for years I've been using SharpCap, and I use the free version. And this past year I sprang for the pro version, which is a yearly subscription of, I don't know, $25 or something. And anyone that's isn't using the pro version, get it. It's great. It gives you a lot more control, and there's a polar align feature that is wonderful. I've been using it with my newer Explore Scientific mount, which doesn't have a polar scope, just has a peephole, and I can dial in a really good polar alignment using that SharpCap feature in a few minutes, and I've been getting good 2-minute unguided subs. So it's cheaper than buying a PoleMaster.
Anyone else? Okay. Well, that's it for this week. I'd like to thank everyone for attending. I shouldn't say this week, this month, for attending. Our next meeting is October the 1, and Marcin Sawicki from SMU is our speaker next month. So look forward to the details on his presentation. In the meantime, stay safe, stay healthy, and keep looking up. The sky is open. Bye all.